This is the Unit 3 Lesson 2 review video. So today we learned about how to interpret mixed number quotients. So before we get into all of that, I think we're going to need to define a few terms. We've been talking about division problems with a total, a group size, and a number of groups. So the way we've been using these is we set up a division problem. We say the total divided by the group size will give us the number of groups. When we're talking about the word quotient, that belongs to a different set of terms that also go with division problems. It goes with the set of terms that are dividend, divisor, and quotient. So the total, another word for that when we're doing division problems, is dividend. The group size, when we're working with division problems, is the divisor. And that answer, that number of groups, is the quotient. In class, we talked about the fact that the word quotient comes from the Latin word quotients, which means how many. So it has its roots in this word, quotients, which means how many. And that answers, the quotient answers that question, how many groups? The quotient question, the dividend divided by the divisor equals the quotient. You start with one number, you divide it up into groups of a certain size, and you get a certain number of groups. Okay, so now that we have that vocabulary down at the bottom, let's take a look at this question here at the top. How many rhombuses fit in the trapezoid? Now we had two competing answers in class today. One group said 1 1/3 rhombuses fit in the trapezoid, and the group said 1 1/2 rhombuses fit in the trapezoid. Let's look at how each side justified their answer. So the people that said 1 1/3 said, look at this trapezoid, right? Here's the rhombus. We're going to put the rhombus over the trapezoid. We see that that fits there. Whoops, those magnets are not very strong. And then we have this triangle, which fits here. And this triangle is 1/3 of the trapezoid, so I think that 1 1/3 would be the answer here. However, the other side refuted this claim, and they said, well, one rhombus fits in, and then this triangle also fits into the trapezoid, but this triangle is half of this rhombus. And we decided in the end that that group was correct because we're asking about a group size of rhombuses. And so that half, that extra triangle that fits in, it should be given in relation to the rhombus, not the trapezoid. So we could kind of use these shapes to represent this division problem. A rhombus is our total. We're dividing it into a group size of rhombuses. Those rhombuses are each one of the groups. This is like the size of each group. And then the number of groups that we get is 1 1/2. Okay, now we come to the very, very center of our lesson. So this is the most important point in this video. If you remember nothing else, remember this part. When we look at this mixed number, and a mixed number is a number that has an integer, which is like a whole number part, and then a fraction part. When we look at this mixed number, the whole number part represents how many whole groups fit into the total. One whole rhombus fits into the total. The fraction part of the mixed number represents how much more of that group size could fit into the total. That's why we had to say 1/2 instead of 1/3, because one whole group fit in, and then half of that group size, which is represented by this white triangle, also fits in. So that's what that fraction part represents. Okay, we then moved on to working with this same concept, but just with numbers, not with shapes. So these are great to visualize it, but oftentimes you'll be asked this sort of question just with numbers. So we moved on to a question that asked, and let me write it out really quickly. It asked, how many groups of 1/2 fit in 2 3/4. Okay, let's identify in this problem each of the elements that we've broken our division problems down into. So in class we identified that the number of the group size would be 1/2 because of this term here, groups of 1/2. There's lots of groups and each of them is 1/2. So I'm going to put 1/2 here above group size. And let me just set up my other pieces of the division problem. So I've got my division sign and my equal sign. And then we determined that 2 3/4 would be the total. And I'll put that here. 2 3/4 is the total. You could also call it the dividend. 1/2 is the group size. You could also call it the divisor. Okay, now you may be able to guess at this point that 1/2 does not cleanly go into 2 3/4. Let's think about what numbers 1/2 would actually go into, right? 1/2 fits into whole numbers because each number has 2 1/2s in it, and 1/2 also fits into numbers that are like 1.5, 2.5, 3.5, right? Because each of those whole numbers takes 2 halves, and then the extra half is just another extra half. All right, to make this a little clearer, let's make a tape diagram. Tape diagrams are super useful for fraction division because they can really help us use repeated addition to see how many of the fraction is going to fit into the total. Now I'm going to erase this bottom line, but we'll just remember dividend, divisor, quotient. Okay, and you can always remember that the number of groups is quotient because it comes from the Latin word quotients, which means how many. All right, let's make boxes, each of which are 1/2. And we'll try to count up till we get kind of close to 2 3/4. So we start with a box that's 1/2. All right, that's just 1/2. We do another one. Now, how much do we have in total? 1, because 1/2 and 1/2 is 1. So I'm just going to make a quick note over here that we're up to 1 so far. All right, let's add another 1/2. So now we're at 1/2, 1/2, 1/2. That's 1.5. Add another 1/2. Now we're all the way up to 2. We've got 2 whole numbers here. We're getting kind of close to where our total is. Not quite there yet, so let's see how close we can get. If we add another half, we're now at 2 1/2. Now that's pretty close to 2 3/4, right? So you might be tempted to think, okay, so in 2 3/4, there's 1, 2, 3, 4, 5 groups of 1/2. Yes, there are, but we're not quite at 2 3/4, so we need to add a little bit more. But we can't add another whole 1/2, because if we do, look what would happen over here, we'll get all the way to 3, and that's too much. We've gone too far. So to get from 2 1/2 to 2 3/4, we're going to have to just add 1/4. A lot of people in class were talking about the fact that 2 1/2 is the same thing as 2 2/4, right? So we can add another quarter, and I'm going to make this a dotted line to show it's kind of like a little extra addition. 1/4 there. And now we're at 2 3/4. But how do we explain that 1/4 that we've added at the end, right? Because it's not a half. We have 5 halves in here, and then we have a 1/4. Now, if you remember with the trapezoid and the rhombus, we have to interpret that extra little piece that's kind of like our white triangle piece, right? It wasn't a rhombus, it was half of a rhombus. So we have to interpret it in terms of our actual group size. Our actual group size is 1/2. How much of 1/2 is 1/4? This is 1/2 of 1/2, right? If you take a half, you split it in half, you get a quarter. So now I'm counting in groups of 1/2. Here's 1 group of 1/2, 2 groups of 1/2, 3 groups of 1/2, 4 groups of 1/2, 5 groups of 1/2, 5.5 groups of 1/2. Okay, so the answer to the question, how many groups of 1/2 fit in 2 3/4, is this number over here. This is the number of groups. This answers our quotient question, how many? 5 and 1/2. Okay, last thing we're going to do, getting back to what we were talking about before with mixed number quotients. This is a mixed number quotient because we have an integer and we have a fraction, and it forms one number. This isn't just like a 5 and then a 1/2. This is 5.5. So the integer part of this quotient represents how many times 1/2 fits inside the total. The whole 1/2 fits inside the total. And this fraction part represents the extra piece, that little extra piece we had to add in. That wasn't quite a full group. It was only half of a group. We had groups of 1/2, and then we couldn't fit any more 1/2s in. We could only fit a quarter, and a quarter is half of a group. All right, that is the point of our lesson today. We went over the geometry that goes along with this lesson. We've gone over some of the division sentences that go with this, and one of the diagrams that we can use to represent this. Tape diagrams for repeated addition of the group size are really, really useful here and are going to be a great strategy to help you on both the exit ticket and the homework and for further exams and whatnot. So good luck with your homework, and I will see you tomorrow.